All right, welcome back to the 7-6 video 2, still working with adding or subtracting polynomials. All right, so we are starting out on page 14, and we're going to do a warm-up problem with this business application here. So the profits of two different manufacturing plants can be modeled as shown, where X is the number of units produced at each plant. So we have the eastern plant and the southern plant. Now, write a polynomial that represents the difference of the profits at the eastern plant and the profits at the southern plant. All right, so we want the difference, which hopefully you guys would realize to subtract. So I'm going to take the eastern plant, negative 0.03x squared plus 25x. I'm going to 2 pencil mark trick that now, plus negative 1500. And I'm going to subtract the southern plant. So negative 0.02x squared plus 21x, and then again, I'll 2 pencil mark trick that, plus negative 1700. All right, so I'm writing them in parentheses because they are polynomials and they do go together. Now, hopefully you remember when we find the difference in polynomials, we want to distribute a negative 1 to the second polynomial. So I should have positive 0.02x squared plus negative 21x, and then plus 1700. So now I can go ahead and vertically add, all right? So I'm going to copy down my first polynomial, negative 0.03x squared plus 25x plus negative 1500, and I'll make plus 0.02x squared plus negative 21x plus 1700. So I'm just copying down my second one. And I can use this vertical addition because I've already dealt with the negative. Okay, really, I've turned all of these terms into opposites. All right, so if I add, I can use a calculator whenever needed. I should have 0.01x squared plus 4x plus 200. And there's my answer for the polynomial that represents the difference of the profits between the two plants. All right, so to finish up 7-6, right, we knew how to add and subtract polynomials. Now we're going to apply it to geometry. And you may see questions like this on the Keystone where you're like, why am I seeing shapes? That's geometry. That's my next course I'm taking. However, what you do with the geometry problem is algebra. All right, so let's take a look at number 5, where we're asked to find the perimeter of the equilateral triangle to the right. Now, you've seen triangles in your math courses before. Equilateral means that all three sides are equal, okay? So if I take a look here, I have two sides that are labeled. The first thing we do is we label that third side. So equilateral triangle, all three sides are the same. And again, in your math career somewhere, you learned that the perimeter would be the distance around a polygon or the distance around a shape. So if I am going to walk the perimeter of, let's say, the track, I'm going to walk the outside loop around the track. If I'm going to walk around the perimeter of a classroom, I'm going to walk along the walls. So the perimeter of this triangle would be walking along this triangle, which means I need to add all of these binomials. So I have x to the third plus 5 plus x to the third plus 5 plus x to the third plus 5. So I wrote it 3 times. I'm going to move it over here just a little bit. All right. So now, excuse me, I can take a look at this, and really it's adding monomials at this point, right? Or if you would like to, we can vertically add all the like terms. So I am going to put some coefficients in there. I'll make them a different color. 1x to the third, 1x to the third, 1x to the third. So 2 different ways to do this. Number 1, I can add monomials, and I can put a plus sign here, and I can say, well, I'm going to add this monomial, and this monomial, because they have the like bases to the like exponents. So 1x to the third plus 1x to the third plus 1x to the third is really 3x to the third. And then 5 plus 5 plus 5 is 15. And now let's call it units. So the distance around that equilateral triangle is 3x cubed plus 15 units. Now, if I didn't want to add them like monomials like we learned at the beginning of section 7.6, if we wanted to vertically add, I could have x to the third plus 5, x to the third plus 5, and x to the third plus 5. Now, all of my like terms are on top of one another. So 1 plus 1 plus 1, 3x cubed, 5, 10, 15. And again, units. So you could do it either way. Okay, whichever way you seem to be getting the correct answer, more so than not. All right, I encourage you to do it that way. So the perimeter around the triangle is 3x cubed plus 15 units. Now let's find the perimeter of the rectangle. Okay, so here's a rectangle. What we know about a rectangle is it has 4 sides, and 4x plus 3 is the same as 4x plus 3. You always label your open sides. Okay, and then 2x plus 2. Always label your open sides. All right, so now I can do vertical addition here. And so let's start. I have 4x plus 3 plus 2x plus 2 plus 4x plus 3 and then 2x plus 2. Like a big old addition problem. So if I add my coefficients, 4 plus 2 plus 4 plus 2, I should have what? 4, 6, 7, 8, 9, 10, 11, 12, 12x. And then 3 plus 2 is 5. 3 plus 2 is 5 plus 10 units. You could also, write it out and add them like monomials like we did up here in this problem. You should still come up with the same answer of 12x plus 10 units. And last but not least, it says find the perimeter of the square with side lengths 3x minus 9. And notice you have a square. Even if you weren't given a square on the problem, you're going to draw a square. You know what a square looks like. Okay? So I'm given a square and nothing is labeled. I'm labeling every single side. And again, we're asking about perimeter, meaning the distance around. So, excuse me, I can go ahead and vertically add. And I can do plus negative, right? I can make these all 2 pencil mark tricks. 3x plus negative 9, so that's this one and this one. 3x plus negative 9, this one, and I have one more. One of the common mistakes is if you have a figure that only has one side or 2 sides labeled, you only add those 2 sides to find perimeter. Kind of like up here, where maybe you would only add these 2. But you know that you have to include the opposite 2. So that's why it's super important to go ahead and label every single side. All right, let's go ahead and let's add these vertically. All my negative 9s should add up to negative 36. And then 3, 6, 9, 12, 12x. So the perimeter of the square should be 12x plus negative 36 units. So this is how you can apply it to geometry, where you have polynomials or binomials or trinomials, whatever it may be, to find the perimeter of certain figures. All right, thanks for watching.